go ahead and take a look at this next example. We've got r equals 4 times sine of theta. And we want to go ahead and convert this equation to rectangular form, and we'll go ahead and sketch it on our polar grid as well. Notice we have access to some other equations, hopefully that will help us along the way. We have the equation x equals r cosine theta, and we have the equation y equals r sine theta. And it looks like we might be able to use the second equation in this example. The only problem is we don't have an r on the right-hand side of our equation. So let's go ahead and multiply both sides by r. And that's going to give us r squared on the left, and we're going to get 4r sine of theta on the right-hand side. So we can go ahead and replace this r sine of theta with our y value. It's going to give us 4y on the right, and we want to be able to replace the r squared piece that we have on the left. And remember that r squared is equal to x squared plus y squared. So let's go ahead and replace that. Okay, and now we have an equation that's in rectangular form. We have only x's and y's in it. Well, let's go ahead and manipulate this equation. It's actually the equation of a circle. It might be a little bit easier to see the center of the circle and the radius if we put it in standard form. So let's go ahead and subtract this 4y from both sides. That's going to give us x squared plus y squared minus 4y. I'm going to go ahead and leave a blank right here, because I'm going to have to complete the square on this left-hand side. And on my right-hand side, I'm going to have 0. I'm also going to add a blank to that right-hand side, because whatever I add to the left, I'm going to have to add that same number to the right-hand side when I go to complete the square. So let's go ahead and work with our y terms here. When we're completing the square, we want to work with our coefficient in front of the y term, which is the 4, and we want to go ahead and divide this by 2 and then square it. 4 divided by 2 is going to give us 2, and 2 squared is going to give us 4. So I'm going to put the 4 on each of these lines. Right, because if I add it to the left-hand side, I have to add it to the right as well. Now, the whole point in doing that is that what you've created here with your y terms is a trinomial that you can factor. Right, so I'm going to go ahead and bring down my x squared piece. And for my y terms here, let's go ahead and factor this. Right, the y squared minus 4y plus 4 is going to factor into y minus 2 times y minus 2. And that's what we want. It should be the same thing in both sets of parentheses. We can rewrite this as y minus 2 quantity squared. And on the right-hand side, we had a 4. Keep in mind that's the same thing as our radius squared. If you want to rewrite it as 2 squared for right now, just so you can see it, that would be fine, right? So our center is going to be the point 0, 2. And this is going to have a radius of 2. We'll go ahead and put our standard form of a circle equation up here. It's x minus h, the quantity squared, plus y minus k, the quantity squared, equals r squared. Okay, hk in this case would represent your center, and obviously r represents the radius of your circle. So if we try to sketch this on our graph, we have a center at the point 0, 2. So here's our center. I'll label it with a C. And then we have a radius of 2. So coming 2 units in each direction. And then we can go ahead and connect those points to form our circle. Hopefully you're a better artist than I am, and do your best to make that the sketch of the circle. there's our circle. Okay? And this would be the graph of the equation r equals 4 sine of theta.